Today, we're going to continue looking at scatter plots, but we're going to look at creating a regression. So that first definition sentence, fill in the blank at the top. A calculator can produce a regression to model the relationship between two variables. And a regression, you did a little bit in eighth grade math, doing that line of best fit. A regression is just a lot more precise than just eyeballing with a line of best fit. So we're definitely using the calculator to produce these regressions. And I'm going to model each of these. This is a little bit of accumulating lesson. And the reason we do it last at the end of the year, because we're going to be able to identify regressions based on, they're going to name it in the problem, which ones we need, either linear, a line to model our data in the table, quadratic with a parabola, or exponential. So now at the end of the year, we've studied all of those different function families and we can do that. So let's look at number one. The number of newly reported crime cases in a county in New York State is shown in the accompanying table, where X represents the number of years since 2007 and Y represents the new cases. Write a linear regression equation that represents the set of data, rounding all coefficients to the nearest tenth in our equation. I'm going to switch colors here. Then, part two, using the equation, we'll find the number of new cases for 2019 rounded to the nearest whole number. So let's start with the linear regression. It is obviously going to be y equals mx plus b. I'm going to grab the calculator here in a sec and plug in all of our information. So in our calculator steps above, it says we're going to go to list in spreadsheets. You can do this a couple different ways. You can go from a new document and it's going to give you that list of like a calculator page, graph page, and then number 4 is going to be list in spreadsheets. You can also go down here to the little apps at the bottom, and the middle one is list in spreadsheets. I'm going to model going from a new document, and here's that list. I'm going to go to number 4, list in spreadsheets. Doesn't matter which way you go. We're going to get a spreadsheet here, and we're going to enter each value into column A. So looking at our table over here, I'm going to enter in 0, 1, 2, and 3 in the first column. Second column, column B, I'm going to put in 1027, enter another 1027, 1094, and 1096. Okay. At the very top of each column, we're going to name them. Right next to the capital letters A and B, we're going to name them. Now you can keep this super simple. We can just name it like X and Y. I think I'll model that here and then model doing something a little more elaborate on maybe number 2. So let's do naming it X and enter, arrowing over to the B header, and I'm going to call it Y. Obviously, you could type in years, you could type in 2007 or something like that. And then in the other one, you could do cases, something like that. So let's go back down into our data. We're going to hit menu. Number 4 is statistics. Just reading our steps there at the top of our notes there. Number 1, stat calculations. And then we're going to choose which type of regression we want based on the problem. In the problem, it literally said, find a linear regression. So that is number 3. Linear regression, it already kind of has like mx plus b listed there. We have to tell our calculator what columns we want it to use, because I could have built more columns. I only built 2, but the calculator wants to know what I want it to do. The X list, we called it X. So it's really important that you label them, right? If I drop down this list, I wouldn't know what my X column was in my Y column. In the Y list, I'm hitting that enter and going to select Y and using that tab key to get me down to the bottom. I don't need to change anything else. So I have my column A and B, X and Y, where I put in the data, and to the right, it's now put in our information, the title, linear regression, mx plus b. It's even writing there that the equation would be mx plus b. My m value to plug in is 27.4. My b value to plug in is 1019.9. The directions in our problem said round all of our coefficients and our values to the nearest tenth. So let's write this out. So we have y equals, the m value is 27.4, plugging that in, x, and then plus our b value was 1019.9. If there were more values, I can always look at that very bottom spot down here to see if there's more decimal places, this value here, that box there. if I needed more digits to help me round. So that's going to be part 1. Let's switch to orange and let's do part 2. Using the equation, find the projected number of cases for 2019. Now remember, back up here, I circled that X is the number of years since 2007. So 0 would have been 2007. 1 would have been 2008. So if we want new cases for 2019, let's subtract. 2019 minus 2007 is 12 years. So just be mindful. Some of the problems, we can take it straight from the table as our X value. Others, we're going to need to do something like this. So we're going to be plugging in 12 for our X in our linear regression. Y equals 27.4 times 12 plus 1,019 and 9/10. Grabbing our calculator, I'm going to add a new page so I can do this calculation. 27.4 times 12 plus 1,019.9. So our direction said round to the nearest whole number. So we have Y equals 1,348 and 7/10. The 7 says round it up. So we're going to have about equivalent 1,349 new cases in 2019. Now, what does this mean? Based on our table, there is a slight trend that is linear, a line of best fit, and we just estimated in the year 2019 that there would be 1,349 new cases in New York. Let's look at number 2. We've got a rocket is shot off from a launcher. The accompanying table represents the height of the rock at given times, where X is the time in seconds and Y is the height in feet. Write a quadratic regression equation for this set of data, rounding all coefficients to the nearest hundredth. Switching colors, part 2 will use the equation to find the height to the nearest foot at a time of 3 seconds. And this said to the nearest foot. So again, like nearest whole number. So recall a quadratic regression in standard form would be ax squared plus bx plus c. We're going to grab our calculator. We're going to type this information into a table, and it's going to tell us the a, b, and c value to plug in for this quadratic regression equation. So I'm going to do a new page, list and spreadsheets. I'm going to type in my numbers here, 0.6. and 0.3, 1.8, 2.5, and 3.1. Going over to the B column, 108, 218, 285, 368, and 436, okay? Let's go up to the A column. Now, I've already used X and Y. I'm going to model that. So let me call this something different. Let's do like seconds, and you can just use your keyboard down here. In B, I'm going to call it feet. Okay, coming down into my data, menu, statistics, stat calculations. We were asked to find a quadratic, which is number 6. Okay, now, if you thought, I'm going to do my own thing, I'm going to call it X and Y. When you open this list, it's a mess, for 1. 2, you're probably going to see 2 X's, or it may have given you a error message. I'm not sure. But that's why I went ahead and named it something different. We did seconds for the X column. This X and Y down here, that's from my first page, okay? That X and Y. So seconds was my X, tab. Let's do feet for Y, tab, 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 all the way to OK. Okay, so column A, seconds, column B, feet. From this second problem, I told it to give me a quadratic regression. There is my formula, ax squared plus bx plus c. I can see it written in a little bit of yellow box, but it's also written down in the bottom gray equals box. And then our a value should be negative 12.445. And there's more. Do you see in that gray box at the bottom? There's a 149 if I needed more. And then B is 176.3. C 77.7096 and on. Okay, in our equation, we are rounding, in our equation to the nearest hundredth is 2 decimal places. I will have to look at the third to tell me how to round. Okay, so we have y equals, that A was negative 12.445, but we're rounding to hundredths. So the 5 is telling me round up that hundredths place to a 5. Negative 12.45x squared, don't forget those essential pieces, plus our B is 176.308. The 8 would round it up to 31x plus our C value is 7.709. The 9 says round that up to 0.71. So 7.71. There is your quadratic regression. Switching to purple for part 2, we're going to use the equation to find the height to the nearest foot, whole number, at the time of 3 seconds. So x is 3, right? So 3 seconds, we just need to plug in a 3. So taking our equation, y equals negative 12.45, 3 is going to get squared plus 176.31 times 3 plus 7.71. Let's put in our calculator and remind ourselves we're going to round to the nearest whole number. So I'm going to grab myself a new page, calculator, negative 12.45 times 3, using my keyboard here, squared, plus 176.31 times 3, 7.71. We have 424.59 rounding to the nearest foot or whole number. The 5 says round it up. So we're going to have final answer. Well, let me put this. 424.59 rounded to the nearest whole number. So the 5 says rounded up. So we have about 425 feet. So let's go back to our problem. What does that mean? So remember, we're talking about a rocket. So we found when x equals 3, we did have some values that were very close to 3. We had 3.1 at the bottom of our table, and it was at 436 feet. Now, this is a scatter plot, remember? And we're just kind of getting a model, a quadratic to kind of shape these points. I have seen problems, listen to me, listening up. I have seen problems where it says like, find the feet at 3 seconds and 3 is in the table. Guess what? Newsflash. It's not going to be that answer because remember, this is a scatter plot. So that one point maybe in the table, that's the same number Delta Mass asking you to find. When you calculate all the other scatter plots along the way, it doesn't fit anymore, okay? So make sure you're not just going to steal the number from the table. It's going to be wrong, promise you, okay? Some other things I love here is that this is a frowny face parabola, right? Which is going to be the shape of that rocket as gravity pulls on it. We also know that it is being shot from 7 and some feet off the air, right? That's our y-intercept. Just a little review there. All right, last one, number 3. The accompanying table shows the value of a car over time when it was purchased for $16,400, where X is years and Y is the value of the car in dollars. Write an exponential regression, rocket ship, or this one's decaying, right? We're losing value in our car. For the set of data, rounding all our coefficients to the nearest hundredth two decimal places. After that, we're going to use the equation to find the value of the car to the nearest cent. What's that? Hundredths places. Again, 2 decimal places after 8 years. So exponential y equals a times b to the x. Let's grab the calculator. Let's load in this information and build our exponential regression. All right, I'm going to actually show you. You might prefer to always go home and start a new document because remember, that's going to end up clearing everything out and we can start fresh and go back to using X and Y and keeping life super easy. Remember, you always don't want to save. I don't know why you would want to keep this, and that would bog down your memory, slow down your battery. So let's grab a new list in spreadsheets and let's type in our years. We have 0, 1, 2, 3, 4. And in column B, at 16,400 that it was purchased with for 13,630, 12,399, 10,351, and 9. There we go. Okay, column A, keeping life simple. X, column B, Y. Going back down into my data menu, statistics, stat calculations. We were asked to find an exponential regression. It's further down, letter A, we have chosen to keep life simple, X and Y for our X and Y list. Tab to get me down to OK. You can see the data that we entered, and beside that, they have given us our exponential regression, a times b raised to the x. Our a value should be the 16,080, and then b is 87 hundredths and some. Now, interesting enough, right? Our A value is not specifically the 16,400. Why? Because this is kind of a scatter plot, remember? So it's not precise, it's not accurate. Who knows how they got those values, but we have y equals we are rounding to the nearest hundredth. I've got 16,080 hundredths. Do you see how in the box, in the cell, in the list, it just shows 0.6 dot, dot, dot. I've got to look down at that bottom line in that gray, and I can see it's 0.69496. You see that? So we had 16,080, and round to the nearest hundred, 694 says let it rest. So 0.69 times our B value. And I think I'm actually going to use parentheses to remind myself that this is multiplying here, 0.871, so just 87 raised to the x, okay? There is your beautiful exponential regression. In part 2, we're going to take that and find after 8 years, our x values are just the number of years, so no big deal here, just plugging in 8. So y equals the 16,080.69 times the 87 hundredths raised to the 8th power. Let's grab our calculator. We are rounding to the nearest cent, hundredths place. So control, I'm going to add a new page, a calculator page, doing the 16,080 and 69 cents times 0.87 raised to the 8th, round to the nearest cent, 2 decimal places. I have a 5,277.87014, blah, blah, blah. Rounding to the nearest cent, the 0 says let it rest. So final answer, 5,277.87 is our final answer there. And so that concludes our scatter plots. And so remember, these are scatter plots, not accurate data necessarily for the number of crime cases or the rocket or the value of the car. They're still random dots, but we're using our calculator to find that regression model that kind of pulls it all together. So again, if you see a value in the table that it's asking for, finish it out and calculate it using our calculator, linear, quadratic, and exponential. All of the problems are going to tell you which type of regression that you're looking for. In addition, they're also going to have 2 parts. Notice I use the 2 different colors. You're building your regression and then you're applying it. So read closely also to the rounding. Make sure you're rounding to the proper place. Guys, let me know if you have any questions, and I hope you have a great day, and I'll see you in class.